So here we have our first sample question for the quiz. Remember, your quiz is going to have 3 questions. The first question is going to be asking you how to simplify a radical expression. You should know what a radical expression is by now. It is basically a fraction that's made up of coefficients, variables, exponents, and if there was any constants. So how do you approach, or how do you simplify any fraction? Remember, we said you factor out the top, you factor out the bottom, and then you see if you have any matching factors. Now factors means that we have to have multiplication. This is subtraction. So you can't say, well, there's a v squared on top and a v squared at the bottom, they cancel out. Do not do that, because the dominating guy here is subtraction. We need to factor, get them into parentheses, multiplication, and then we can cancel out the same parentheses. So you're going to factor out the top separate from the bottom. So let's take a look at the top. 6v squared minus 9v. So we always ask you, the first step to any type of factoring is see if you have a GCF. Remember what you're looking for. You're saying, do we have matching set of parentheses? No. Do you have the same letter in every term? Why, yes, we have a V. So we do have a GCF. When you have the same letter, we always told you, grab the smallest exponent. So we have a 2, and we have nothing here, which is understood as a 1. Do we have anything else besides V? Well, remember, the third thing we asked you to check, does it have a number? And if you gotta remember that 6 can factor out as a tree diagram, 2 times 3, and 9 can factor out as 3 times 3, so they both have a factor of 3. Okay, remember, 2 times 3 is 6, 3 times 3. So we know we can take out a V, a 3, and does this start with a negative sign? Remember, you gotta catch that. If your polynomial ever starts as a negative, you must take that out as part of the GCF. If it's positive, like these two guys, then you can skip it. So now that we know what our GCF is, we gotta figure out what our leftovers are. Okay, so the GCF is one factor, and our leftovers would be the other type of factor. So let's see what we have left over. So if I take out a 3v out of this term and a 3v out of this term, remember we just divide by our GCF to see what's left over. 6 divided by 3, you know that's 2. Remember, if the 3 comes out, 2 is still left. And remember, I have v squared, that means 2 v's. If I only take out 1 v, I'm left with 1 v left. And we do the same thing here. You can divide, -9 divided by 3, you get a -3, or you could just say, oh, a 3 on top and a 3 on the bottom cancel out. So I'm left over is at 3. A v on top and a v on the bottom, 1 for 1, they can cancel out. So I'm just left with a -3. So either way, some of you are my factoring people, and others are my division people. Whatever you see is left over, just make sure it's in the same parentheses as all your leftovers. Now, just because you have a GCF doesn't mean you're done yet. We always said that you have to check to see if you can factor this even further. So once you find out that there is a GCF, look at the leftovers and see if you can factor this out further. Count how many terms? 1, 2. We told you if there's 2 terms, the method is difference of squares. Remember all the things with difference of squares? You must have a minus sign, check. And you must have perfect squares. 3 is not a perfect square, not a perfect square, not a perfect square. If one of these is not a perfect square, then you can't have difference of squares, okay? So then this is considered factored on top. Now that we know the top factors out as 3v and then 2v minus 3, let's factor out the bottom. The bottom, again, the first thing you want to do is see if there's a GCF. Do you have matching set of parentheses? No. Do you have the same letter in every term? Yes. When you have the same letter, make sure that you grab the smallest amount. Remember, smallest amount is exponents. 2 versus an understood 1, you can only take out v to the first. Is there any numbers? 3 and 15? Remember, you have to do a tree diagram. So 15 you can break down as 3 times 5, so you can see they both have a hidden 3. So you can take out a 3. And does it start with a negative? No. So remember, you're checking the 4 things: matching parentheses, looking to see if they have the same letter in all terms, see if they have the same number factor in all terms, see if it starts with a negative. Those are the 4 things to look for GCF. Once we know what our GCF is, make sure you divide each term by the GCF to get your leftovers. So 3 divided by 3, 3 on top, 3 on the bottom, cancel out. V squared over V means that you're left with 1 extra V on top. And then negative 15 divided by positive 3, you know you're going to get a negative 5. V over V, you know that cancels out. So we want to look at our leftovers. Remember, to see if we can factor these out again. So we have 1, 2. 2 terms. The only method we can do is difference of squares. Notice this is not a perfect square. Even though it has a minus sign, if one of these 2 pieces are not a perfect square, then we can't factor it out any further. So notice I factored out the top, I factored out the bottom, and I'm going to see if there's anything that matches. Do we have any matching parentheses? Does this and this match? No. But clearly 3v and 3v match. So they cancel out. So then your answer is going to be 2v minus 3 over v minus 5. If you want to keep the parentheses, you can. If you don't, that's fine as well. Okay. The only other thing that I want to point out is some people might not have these match exactly. So let's say that instead of this being 3v minus 15, let's say this was a 5. If that was a 5, you would have taken out a GCF of, you would have taken out a GCF of 5. And the reason why I'm pointing this out to you is because what happens if you had this on top, 3v, 2v minus 3, but a 5v and a v minus 5. What happens if you had that? Now a lot of people say, wait, I have 2 parentheses that don't match, and then they say, oh, these don't match. But remember, this has no addition or subtraction sign. Because this has no addition or subtraction sign, these don't have to be in parentheses like this. So this is actually saying 3 times v times this whole guy. We could do the same thing here. This is really 5 times v times this whole set of parentheses. Monomials, we're allowed to break them out and don't need to have parentheses. Binomials, you must have parentheses. Now why am I pointing that out? Is because then you can see that a monomial v can cancel out with a monomial v. You cannot do that here and here because this is binomial v. This is married to the 5. This is married to the 3. You cannot cancel out this and this because you can't cancel out the 3 with the 5. But when they're monomials like this, you can. So for our original problem, notice they matched exactly. But some of you might get something that they don't match exactly, but you can at least cancel out the variable part, okay? Because these are mononomial v's with mononomial v's. So again, just factor out the top, factor out the bottom, look for GCFs or any other method, see what matches the top and bottom. Remember, mononomial with mononomial you cancel out, binomials with binomials, as long as they match exactly.